Okie doke. Now, so from yesterday, we learned about calculating the pH. What? The mouse off the screen. No. What difference does it make? All right. All right. Man, you are just so needy. What can I say? All right. I'll try. That's all I can tell you. All right. Now, so yesterday we learned that from the molar concentration of either, if we're going to use the Rainiest system of thinking about acids and bases, or if we're going to use the Bronsted-Lowry system of thinking about acids and bases, we calculate the pH by negative log of either one of those. Okay? All right? In the homework problem, we calculated the pH of the solution to be was 2.26, right? Okay. Is anybody here taking honors level algebra? Okay. So you may have already been exposed to logarithms. And if you're exposed to logarithms, you should already know, because only honors algebra deals with logarithms. I don't think CP actually does it. Even though I plead with CP teachers every year because we're going to do logarithms in here. I just send them an email letting them know.
Is honors advanced?
Honors is more advanced than CP, which is more advanced.
I'm talking about like.
He means is advanced count as honors if it does.
Actually, you mean AP? AP is actually college credit. Now, let's stay on task. Here's what you might not know if you haven't taken honors algebra 2, and that is that logarithms are just exponents. Okay? So get out your calculators, play a minute. Imagine. Okay. Let's see. What is 10 squared? 100. I want you to find the logarithm of 100. What is the logarithm of 100? Did you do it on your calculator? So there's the logarithm. It's the exponent on 10. Now you can do a logarithm on a lot of different bases. 10 is the base here. And with the newer calculators, the math department's using the Inspire calculators. You have to actually enter the base. But for most calculators, if you put in LOG, that's a logarithm on a base of 10. Okay? So all we're doing when we're doing pH is finding a logarithm. Got it? It's a little more complex when you multiply some number times that 10 squared. It gets a slightly different number. That's where you get those fractions from. It's not nice and even. All right? Let's try this. And what is this in exponential notation? Let's put a 0 here. What is this number in exponential notation? Scientific notation. 10 to the negative 3. 1, 0, because I got a 1 and a 0 here, times 10 to the negative 3, right? All right? Find the logarithm of this. Whoops. What? Negative what? Ah! Gracious. What is it? All right, what's the answer? Right? Yes? All right, then let's do this. And so that's how we get our pH. It's a small number or small molarity of hydrogen ions. Okay? Less than 1, almost always. Okay? Any questions about that? All right. Now, if logarithms are exponents, that gives us a way to undo an exponent, which means we can undo the pH. If logarithms are exponents, then we can undo logarithms, which means we can undo pH. Does that make sense to everybody? We can, if we know the pH, see what we did? We just undid it with exponents, okay? You can undo addition with what operation? Subtraction. You can undo multiplication by what operation? Division. So you can undo logarithms with exponents. Okay? And that's all we're doing. So have you done it? What do you got? Is that what you got? Okay. Let's round it off. And we're going to use the same, even though there's a different set of rules for logarithms and exponents, we're going to use the rules for multiplication and division here. So how many digits do I need? 3. Which means that, and this is, since this is a molar concentration, this is molar concentration. So we're going to round that off then to 0.00550 molar, right? How close is that to the actual concentration we started with on the homework? Huh? You didn't do it in the calculator? Well, have you done it? Did you do the calculation for yourself? What was the answer? What was the actual concentration we started with to find the pH on the homework? What was the concentration of the hydrogen ion that we started with on the homework to find the pH? The homework problem we just went over earlier. What was the concentration of the hydrogen ion in the homework? 549. Awfully close, isn't it? Yeah. The error, the slight difference, is due to rounding. If we didn't round anything, we would get back to the same answer before we started with, okay? So there will be some errors because of rounding. When we round stuff at every stage, like we do in this class, we propagate errors. I want you to know that, but we do it because it's awfully hard to keep up with all the rounding at the very end with all the operations you have to do sometimes to get there. Got it? You know what? I don't want to talk about that right now. I want to talk about this. Okay. So it's really close. Got it? So let's see. If we have the pH of a substance or solution, then we can find the hydrogen ion concentration. We can go from here to here by, go here to here using this operation right here. 10 to the negative pH will get us from here to here. What if I want to go back the other way? I got the hydrogen ion concentration. What? No. That's what you did for That's what you did for homework. Log. Negative logarithm of the hydrogen ion concentration will get you from here to here. Does that make sense? That's pretty cool. But we're going to get way cool now. The next level of cool. Okay? But before we can do that, we've got to talk a little theory.
Oh my goodness.
I don't want to hear complaints right now. No complaints. No complaints. You gonna what? You gonna file a complaint? Feel free. See that? See, you see that round file right up there? The round file. You know, that's where you file complaints in here. The round file. Yeah. The round file. Oh, this one's kind of rectangle. Round file's over here. You don't get it?
Yes, I get it.
Okay. You know you can complain to me if you want to. All right. Question. Yesterday, in the notes, in the lecture yesterday, in the discussion yesterday, there was a definition given to you for what Arrhenius acids are. What was the definition of the Arrhenius acids?
I'll look for you. Hang on a second. I got you.
Okay, but I gave you a verbally in the notes yesterday. I didn't write it out for you.
No.
I ain't your mama. Do I hold your hand?
No.
Okay? I verbally gave you a definition of an Arrhenius acid. Did anybody write it down? Nobody wrote it down? I repeated it twice.
You repeated it 2 times.
Yeah, that's what I probably said. It has no
All right. Shh. 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 Arrhenius acids give hydrogen ions to water. You do have it? Yes. No. Give it to water. It's dissolved in water. Well, that would be Bronsted. Donate protons. It just dissolves them in water. Arrhenius acids break up or ionize to put hydrogen ion in water. Okay. Bronsted-Lowry acids donate protons to another chemical.
So basically, why is it Bronsted-Lowry?
I said that yesterday. He's Danish. He's Danish. And I'm not talking about cheese Danish now.
Those things are so good, you like put them in the microwave.
I don't want to hear it. All right. Look. In both cases, the hydrogen ions have to leave somewhere. In both cases, in both definitions, the hydrogen ions have to leave somewhere. The difference is where they go when they leave. If you think about it, this is a theory now, there's no real difference in what acids actually are. It's just a way of defining it. Okay? Rainiest thought of acids as giving away hydrogen ions to water. You dissolve the hydrogen ions in water. That's all it is. Bronsted-Lowry says those hydrogen ions don't just go into water and float willy-nilly all around. Okay? They actually bond with something in the water. Usually it's another water molecule. Okay? Rainiest bases give hydroxide ions to water. Okay? And Bronsted-Lowry bases accept protons. So acids donate protons, bases accept protons in a covalent bond. All right. And that's one part of the theory. Here's another part of the theory. There's no such thing as pure water. I've told you this before. It's not something new. No such thing as pure water. Even if you get all the dissolved ions out of there and all the dissolved animal parts and insect parts and bacteria, dead bacteria out of there, if you get all that out of there, all the dissolved oxygen out of there, there's still no such thing as pure H2O. Yes?
Would it ever be possible if you made your own
No.
water?
No.
Aren't they trying to do that though in the future, make water?
I don't know. They have something called ultra pure water, but it's not really pure H2O. There's no such thing as pure water. Sorry, thank you. Autoionizes. Okay. A lot of talking going on. It doesn't have anything to do with chemistry.
I'm writing down that. What is the definition of ionizing?
Okay, good question. Let's talk about that. What's an ion? Anybody? What's an ion? Not just negative. It's any charged particle. But it's not just any kind of particle. It has to be either an atom or something that has a bunch of atoms bonded together covalently. More than one atom bonded together covalently. So it can be a single atom that has a charge because it's gained or lost electrons. Or it can be a covalently bonded set of atoms, kind of like a molecule, but it also has a charge. Okay? That's an ion, charged particle. How do you ionize then? How do you ionize? If an ion is an atom that has lost or gained electrons, so it has a charge, or it's a set of atoms covalently bonded together with a charge, how do you ionize something? What? Do the opposite. Duh. Okay? You put extra electrons on an atom. You take electrons away from an atom. That's a monoatomic ion. Or a polyatomic ion, you have to have more electrons than protons, or more protons than electrons. Boom. Right? All right. That's how you ionize. Now listen. What does auto mean? What? Self, or you could say automatically. So water self-ionizes, or automatically ionizes. Okay? Got that? That's all it means. Water makes its own ions, and it splits up to do it. So here's water. And using this Rainiest definition, okay, we can write it. What happens is it's going to break up into ions. What ions can I break water up into? Hydroxide. Yeah, there you go. There's the autoionization equation using the Rainiest theory. Okay? And here's the part that'll blow your mind. Look at this. Since water donated a proton to water, since this molecule donated a proton to water, what does that make this? What does it make it? It's an acid. Look at there. Rainiest acids give hydrogen ions to water. That's what it did. Okay? Now, since water donated a hydroxide ion to water, aqueous means in water, what does that make this? It's a base. Water is both an acid and a base. Now, up to now, you probably thought about water as being neither acid or base, right? In fact, it's not, to a chemist, water is both an acid and a base. Okay? Both. Let's look at how that would play out with the Bronsted-Lowry theory. With the Bronsted-Lowry theory, we can't just take a hydrogen ion off. It's got to go and join up covalently to something else. Okay? So here are two water molecules. So this water molecule is going to split up just the way it did up here. And from here we're going to get a hydrogen ion. And it's going to go up here and join up with this water molecule. Huh? Not more water, because now it has 3 hydrogens in a positive charge. What is that called? We've learned this before. What's it called? Excuse me. Sorry. What do you call that? Alright, we took a hydrogen ion off of here. What was left behind? So the other part of this, right here, you can't just get rid of it. It's still there. We're chemists, we're not God. We don't get rid of things. We don't delete, we don't destroy things. We don't create things. We just move things around. Okay? Got it? So this is the Bronsted-Lowry way of thinking about this. And this is called autoionization of water. This is a way of describing, in a chemical equation, the autoionization of water. Okay? Now, that's pretty neat. We're going to get way more cool than this. Okay? At 20 degrees C, the molar concentration of hydrogen ions in pure, so-called pure water. Well, because it can't be pure, right? We didn't say this. We said that a while ago. There's no such thing as pure water. Okay? We just said that. At 20 degrees in so-called pure water, the molar concentration means moles of this stuff in a liter of water. The molar concentration of hydrogen ions is 1.00 times 10 to the negative 7. All right. That's the way we think about it using Arrhenius. With Bronsted-Lowry, that proton with Arrhenius here didn't just float around in the water. It went and did something. What did it do? In the Bronsted-Lowry theory, because the hydrogen ion doesn't just float around in the water, the way it appears to do with the Arrhenius definition. In Bronsted-Lowry, what does that hydrogen ion do? It joined up covalently with another water molecule. See? I illustrated it right here. Okay? So for every hydrogen ion, we're creating a hydronium, right? For every hydrogen ion from this water, we create one hydronium. Does that make sense? Therefore, if we're thinking about autoionization in terms of Bronsted-Lowry, the molar concentration of hydronium in pure water at 20 degrees C is, for every one of these, we get one of those. It's a 1-to-1 ratio. How much of this do we have? Same number, 1-to-1 ratio. Every time we break up a water molecule, we also make a hydroxide, right? Every time we make a hydrogen ion or hydronium ion, we also make a hydroxide. So if the concentration of hydrogen ions or hydronium ions is this number, what's the concentration of hydroxide? That number. It's a 1-to-1 ratio. All right? All right, we're getting way cool here. Way cool. Extending the theory. Drilling down. Okay? What happens? What number do you get if you multiply either the hydrogen ion times the hydroxide ion concentration or the hydronium ion times the hydroxide ion concentration? What do you get when you multiply those two together? What? Okay, let's work on this right now, okay? What do you get when you multiply the hydrogen ion concentration, right here, times the hydroxide ion concentration, concentration of this times the concentration of that? What do you get?
You get 1.00 times 10
Okay? And I'm multiplying molarity times molarity. So what unit of measurement do I have here? Molarity squared. Yeah. That number is really important to us. Super important.
So what is that again? How did you
Huh?
How did you get that again?
We multiplied the hydrogen ion concentration times the hydroxide ion concentration. Or the hydronium ion concentration times the hydroxide ion concentration. Basically, the products of both these two equations. Hydronium times hydroxide or hydrogen times hydroxide. Got it? We're multiplying those together. We get this number. This number is called the autoionization constant for water. Alright, autoionization constant for water. Autoionizes, autoionization, it's a constant. Let's think. Huh? For water or off water, either one. It's fine. I want to think back a minute here. Remind ourselves about Boyle's law. What was Boyle's law? Pressure goes up, volume goes down. And pressure times volume always gives you a constant. It stays the same, right? Alright. We got a constant here. What's that a constant for? What do we multiply by to get those two things? Huh? That's what we did for Boyle's law. What do we do to get this constant right here? The hydrogen ion concentration times the hydronium ion concentration, the hydroxide ion concentration. So Kw is the product of this molar concentration times this hydroxide ion concentration. If it's a constant, what does that mean? Huh? Stays the same. So if one of the variables changes, what does the other variable do? Goes the opposite way. So it actually turns out that if the hydrogen ion concentration goes up, what is the hydroxide ion concentration going to do? Going to go down. How would we raise the hydrogen ion concentration in a sample of water at 20 degrees C? You have no clue, really? What problem? We haven't got to a problem yet. We're doing the background stuff right now. How do you raise the hydrogen ion concentration in a sample of water? Really? Well, but it's a ratio, so. How did we raise the hydrogen ion concentration yesterday? We didn't have water. Add protons. Where do you get protons from? Where do the protons come from? Well, protons are positive charged hydrogens, yes. They come from acids. Acids do what? So if you put an acid in the water, what would happen to the concentration of hydrogen ions? Go up. If you put an acid in water, what would happen to the concentration of hydroxide ions? Go down. Okay? And it's a mathematical relationship, and we can calculate stuff from it. We got KW. We know that number. That's always the same because of the constant. Okay? We just need to know either one of this one or this one, and we can calculate the other one. What now? Yes. Yes, it is.
Is this the last section where you can do
Okay. All right. Now we're going to go back to what we were doing a minute ago. Okay. We were right here. And we found the hydrogen ion concentration to be what? We found the hydrogen ion concentration to be what? Okay, that number right there. Right? Okay. Now we got this equation right here. We know this value because it's right there. So if we know the hydrogen ion concentration from the last problem, we now have what we need to find the hydroxide ion concentration. There's your problem. Yes. There's your problem. Please do it. What? What? In the last sample, yes. Oh, thank you. Is the last sample? In the last sample. Yep, I got you. In the last sample. Plug it in. Plug and chug. Plug and chug. Really? What was the hydrogen ion concentration in the last sample? Right there. What's the KW? Right there. I got two values with a, okay, just find the third. Just like Boyle's law. You got two values, you find the third. You've been doing this kind of stuff since third grade. You got two values and an equation has three variables. Yeah. Yeah. Well, you didn't call it the same thing in third grade, but you were basically doing the same thing. In third grade, you were given problems with an X in it, and you solved for X. Yes. Yes. 4. So 2 plus what equals 4? You solve those kind of problems in third grade. All right. Who's got it? Does the what have the M on it? Yes.
When you write it 0.0050
No, just molar. 0.0050 molar. And the last problem we came up with that value for the concentration of hydrogen ions. So 0.00550 molar was the value we came up for that. Times the OH negative equals KW, and KW is this number. How do you solve for OH? You can multiply by the reciprocal or divide both sides by. Either one would work. Simplify and solve. How do I simplify? That's how I simplify that side. Can I simplify the other side? No? What's molar squared mean? And that's over molar. How do I simplify? Right? So I can do that. So what is the concentration of the hydroxide ion then? Not 14. Your math is off somewhere. It's negative 12.
How do you do that?
I don't know. I just put this in the calculator like this.
You can write times 10 to
In your calculator? Sure.
Of course you can.
I bet you can. What kind of calculator do you use? Oh yeah, I've got one of those.
You can. I just wasn't thinking.
Oh, okay. Make sure you put the top operation in parentheses, because that's about 3 different math operations in one. Okay? Did you get that same answer then? And we round it off to what? 3 significant digits. So the answer we want is 1.82 times 10 to the negative 12 molar. Alrighty then. Yes. Huh? Sure. Let's go back to our graph here we're working on. Let's go back to this. We now have figured out, guys, y'all are chatting about a lot of things that want to do with this and you're not focused here. I need your focus here, okay? We can now go from hydrogen ion to hydroxide ion concentration using what? There's the equation. That's what we use, right?
Using the ionization constant of water.
Okay? So if I know hydrogen ion concentration, I can find hydroxide. I can also find hydrogen ion concentration from hydroxide because Kw doesn't change. It's always there. Okay? Well, what does pH mean?
Like how acidic the base is.
Ooh, I told you yesterday to think about it in a different way.
Oh, I don't.
You weren't listening yesterday?
I was listening. It was hard to concentrate on the video.
Okay. What does the P in pH mean?
The negative log.
Negative log. What does the H in pH mean? Hydrogen ion.
Oh.
What does pOH mean then? There you go. Negative log of the hydroxide ion concentration. Alright? If I knew, and I did yesterday and you did it for homework, I knew the hydrogen ion concentration. How did I find pH from hydrogen ion concentration? Negative log. So how do I find pOH from hydroxide ion concentration? No, negative log too, because P means negative log. So if I want to go from this direction, I can go here. How do I go back the other way? If I've got the pOH, how do I find the OH concentration? There you go. Just undo it. That makes sense? To a degree. All right. Now, let's go back and look at our stuff right here for how we got Kw. We multiplied this times this, right? Find the pH of this solution. Find the pH of this solution. Use your calculator quickly now to find the pH of this solution. Not right now. Why? I can't right now. Find the pH of this solution. You should get out your calculator if you can't do it in your head and find the pH of this solution. Yeah? No. This is the hydrogen ion concentration. How do you find the pH from the hydrogen ion concentration? How do you find the pH from the hydrogen ion concentration? Just do the math. Okay? So what's the pH of a solution that has a hydrogen ion concentration of this? Yeah, remember when we did all that stuff up here? That stuff right there? 7. Because it's 10 to the negative 7. Alright? Okay. Alright. If I multiply this times this to get 10 to the negative 14, what happens if I add these two exponents? I get 14. And 7 is the pH. What's the pOH of this solution? 7. If I add pH and pOH together, what do I get? 14. What's the maximum amount of maximum pH you can get? 14. Okay. Turns out pH plus pOH equals We only got about 6 minutes. If you have to go, I guess so. Wait a minute. Hold on. Isaac just went. You have to wait for Isaac. Okay. So how do I get from pH to pOH? If I know pOH, I can find pH. So if I know any one of these things, I can find all the other ones. 2 different ways. So you have a homework problem to do, and you have procedures and hazards to do. Well,
Time to do that for you.
I bet if you got started right now, you'd have a good start on your homework. I didn't give anybody permission to chat about things other than chemistry. You should be working on your homework. What? The homework problem? Hi. You said bye or something, didn't you? Okay, you too.